Today I'd like to have a look at gauge blocks, and these are common to the machine shop. They're used as a standard to check other equipment against, such as calibrating a micrometer or doing a build-up to create an angle. And we'll have a look at that in a little while. This is a common set of 83 gauge blocks, and they come in different degrees of accuracy. A AAA set, which is a master set, a AA set, which is a laboratory set, an A set, which is an inspection set, and a B set, which is a working set. Commonly the B set will be found on the machine shop floor, and it typically will hold 83 blocks. In the box here there are two blocks that will be wear blocks. These wear blocks will be at the end of any build-up that you make, because the environment can be hostile, and if we're going to wear any of these blocks out, we want to wear out just two and have to replace those. We then have the fourth decimal place, which goes from 0.1001 to 0.1009. The second series will be the third decimal place, and these ones will go from 0.101 to 0.149. The third series will be the second decimal place. These ones will go from 0.150 up to 0.950. And then the fourth series will be the inch blocks. They will go from 1 inch up to 4 inches. And that will be the complete set of the 83 blocks. Inside the box of the gauge blocks, you should have a certificate which will show you the accuracy of the blocks. Let's have a look, for example, 0.1005 block. It has an accuracy of +1, and the deviation is micro inches, which is 0.00001 inches of deviation. Now you notice some of the blocks are larger than that, but this is a very, very small deviation, and the accuracy will be great. In the example we'll see in a couple of minutes, we're actually going to check the angle of a part that's been machined, and the angle is, for argument's sake, just for this test, is for 30 degrees, 50 minutes, 12 seconds. If we do the trig and we multiply it by 5, because the distance between the centers of a sine bar are 5 inches or multiples of 5, it works out to an answer of 2.5629 inches. We're now going to take this size and we're going to start to look for some gauge blocks for it. The first thing we need to do is we need to remove the wear blocks, which are 200 thou, 100 thou each on each end, so that'll total 200 thou. That gives us a total now of 2.3629. We want to have a look at the last decimal place, and we want to use the first series of gauge blocks in order to get rid of this decimal place. So if we use the 0.1009 gauge block, it will allow us to get rid of that last decimal place. Now you can see the answer is actually 3 decimal places. We want to take this and we want to get rid of the last decimal place, and we want to make the second one either a 5 if it is greater than 5 or a 0. So if we go in the second series of gauge blocks and we choose 0.112 and we subtract that, we end up with a total of 2 inches 0.150. And this has created it with a second decimal place is now 50 or 5. Okay, so if we go into the third set of gauge blocks and we choose a 0.150, it will now give us a remainder of 2 inches, and then we'll choose the last gauge block, which is 2 inches, and that will give us a remainder of 0. So the gauge blocks we're going to use are going to be 2 inches, 0.150 inches, 0.112 inches, 0.1009 inches, and 200 thou wear blocks, which are going to give us a total of 0.200 inches. Here are the gauge blocks we're going to use, and we have them laying on a surface plate. So what we've done is we've pulled out of the set the actual blocks we're going to use. So here is the one wear block, which is 100,000th of an inch. Here's the other wear block, which is the other 100,000th of an inch. The first series, the 0.1009. The second series, the 0.112 inches. The third series, which is the 0.150 inch, and then the fourth series, which is the full 2-inch block. These blocks are hardened, and they're ground and lapped, and they're very, very flat. What we're going to do is we're going to put these blocks together. Before we put these blocks together, we want to make sure that the faces that are going to mate within the next block are clean. So as you can see, it's a good idea to clean them on something such as the back of your hand. The reason we're choosing the back of the hand is because there's less grease and dirt in the back of the hand than there would be in the palm of the hand. You also could use a lint-free rag, which would be another alternative. Okay, now we're ready to start sliding these blocks together. And what we're going to do is we're going to pick them up, and the faces that we've cleaned, we're going to slide in opposite directions. It's called ringing the blocks together. So the surfaces, again, where they're going to mate are very, very flat and ground. So as we slide them over each other, what it's going to do is it's going to create a seal with no air in it, and it will almost feel like they're magnetized together, even though they're not. And the reason for this is so that there's no error in measurement, because if we were to stack a whole bunch of blocks together and there was dirt or air in the middle, we would get an inaccurate reading once we had it all built up. Here are the gauge blocks rung together on the surface plate, and you can see the wear blocks on either end of the build-up, which will come into contact with other surfaces. As stated earlier, we can use the gauge blocks for several different purposes. We can build up an accurate size to do calibration or to set a standard, such as the height gauge we had a look at in a previous video. In this particular clip, what we're looking at is we're looking at a sine bar set up with the gauge blocks. And what's going to happen is it's going to mimic a triangle. So with the angle we've created, we are going to have a triangle here, and what we're going to do is we're going to set some work on top here that is going to mimic this triangle. So we can either check an angle, or we could scribe an angle, or we could machine an angle. Okay, so here's a piece of work that we've set on the sine bar, and as you can see, what we're trying to do is we're trying to recreate the triangle that is going to be on this sine bar, which is mimicking the triangle that's going to be on the bottom here. So this is the angle that we did the build-up for, and what it's trying to do is it's trying to mimic this angle here. And if you have a look here, what we have is we have a sine bar with 5-inch centers. So this is where we are getting that 5 in the trig equation we were looking at. So now that we have this set up, if this piece was machined properly, we should be able to put a dial indicator on the surface and run it back and forth across the top of the surface, and as long as it's 0, it tells us that angle was machined properly. Also too, we could set it up and finish it to this angle, or we could end up scribing to do layout type of work with this type of situation. So here's again the gauge block build-up and a sine bar, and we have several different uses for it. Very, very accurate setup.